Irrational numbers are the numbers that cannot be written as a ratio of two integers. That means they are not rational numbers. And irrational means just that, not rational. We saw previously that the decimal forms of rational numbers, you'll always have some repetition, repeating over and over and over again as the decimal goes on. For irrational numbers, or sorry, I should say for rational numbers, that decimal also might terminate, like 0.25. But for irrational numbers, the decimal numbers go on forever and they never repeat. So a classic example of that is pi. Pi is 3.1415. Sorry, I had to check the last digit. My memorization of pi is not very good right now. 3.141592654, and on and on and on. There's no pattern there, no repetition. It just goes on forever. Another example of that is the square root of 2. Square root of 2 is 1.41421356, and on and on and on. And we could do this with the cubed root of 10 and the fifth root of 20. All of these are imperfect roots, and any imperfect root will be irrational. So let's identify each number as rational or irrational. Square root of 9, well, it has a square root, but square root of 9 is a perfect root. So, or we should say 9 is a perfect square, so the square root of 9 is a perfect root. So it's equal to 3. This is rational. 8.156786,149. What we see is no repetition in those decimals, so this is irrational. The square root of 8. 8 is not a perfect square, so this is irrational. 2.879187991. Ooh, well, just sort of by looking at how it's written, because of the spaces in the decimal form, it kind of looks like there's not repeating. But if we look, we have 4 digits, 879, repeat, the next 4 digits, 8791. So this is actually a rational number because those decimals are repeating. Same goes for E here. At first it looks like they're not repeating, but we have 1, 3, 1, 3, 1, 3, 1, 3, 1. And actually, it terminates. There's not even a dot, dot, dot. So because it terminates, it's rational right there. We don't even have to worry about the pattern. 6 pi plus 4. Well, all this other stuff doesn't matter. The second you have pi in there, if it has infinitely repeating decimals, no matter what you do to it, the decimals are always going to be repeating. So that's irrational. And finally, cubed root of 6, also not a perfect cube. So there are some perfect cubes. There's lots of perfect cubes. Like 8 is a perfect cube. The cubed root of 8 is equal to 2. But the cubed root of 6 is not anything perfect. So this is irrational.